Welcome to the Math Record. This video will cover the second part of the ICTM Regional 2020 Division AA Junior Senior 8%, which I'll be covering questions 14 and 17. Okay, number 14. Determine the secant of the smaller angle between the vector 3, 4, and 12, -5. Express your answer as a integer or as a common or improper fraction. So we could just use a property of the dot product such that cosine of theta is equal to the dot product of two vectors a and b divided by the magnitude of a divided by the magnitude of b. So, so basically, we have cosine of theta is equal to the dot product of a and b. So dot product of 3, 4, 12, -5. So 3 times 12 is 36, and 4 times 5 is -20. So you have to minus a 20 divided by magnitude of A is 3 squared plus 4 squared, which is 9 plus 16 is 25. Square root of 25 is 5. So that's your magnitude. And the magnitude of 12 is -5. So 12 squared is 144. 5 squared is 25. So 144 plus 5 plus 25 is 169. And square root of 169 is 13. Okay, so we have cosine of theta. So 36 minus 20 is 16. Divide by 5 and 65. So that's just 65 on the bottom. So we want to find the secant. You just do 1 over cosine of theta. So just flip the numerator and denominator. So that's 65 over 16. And that is your answer for number 14. You just need to know the dot product. Okay, now number 17. So x squared plus 2x minus y to the power of 8 is expanded and completely simplified. Determine the sum of the numerical coefficient of the term containing x to the power 5. So this would be the expansion of the binomial theorem. So basically, it's kind of the same idea. You just whatever the power is, since it's 8, so we do 8 factorial over whatever you have for the first number. So that's x factorial, and then y factorial, and then z factorial. So these are the exponents for the three terms, and they should add up to 8. And then you basically, whatever the coefficient of the first one, you raise it to that power. So let's just call that as a coefficient, and then b as the next coefficient, and then raise it to the y, and z is the coefficient, and then c is the coefficient, and then raise it to the power z. So it's basically the same thing now. They just as a binomial. Now you just have an extra variable. So if we want to find x to the power 5, I notice that there's an x squared and there's a 2x. So either your x squared is raised to a power 2, and 2x is raised to a power 1. So that's 4 plus, because 2 times 2 is 4, and then times this x is 5. So that's x to the power 5. That means 2 plus 1 is 3. So 5 minus 3 is 5. 8 minus 3 equals 5. So we have our negative y is to the power 5. So that's not the only case, because let's say x squared is the power 1. So this is 2, we need 3 more. So 2x to the power of 3. So 3 plus 1 is 4. So that means negative y is the power of 4. Now let's say x squared is equal to 0. So if that's 0, that means 2x has to go to 5. So 5 plus 0 is 5. And then 8 minus 5 is 3. So negative y to the power of 3. And that's the only three. Those are the only combinations that work. So we need to find the coefficients for each of these, which is pretty simple. For this one, it's just 8 factorial over 2 factorial, 1 factorial, which is just 1, and then 5 factorial. Then multiply by, the coefficient here is 1, so we don't have to worry about it. The coefficient here is 2, and then 2 to the power 1 is just 2. And then negative 1 to the power 5 is just negative 1. And then now for this one, we have 8 factorial. And then 1 factorial, which is just 1. Then 3 factorial, 4 factorial, multiplied by 2 to the power of 3, which is 8. And then negative 1 to the power of 4, which is just 1. And 8 factorial. And then 0 factorial, which is just 1. 5 factorial, 3 factorial, multiplied by 2 to the power of 5, that is 32. And negative 1 to the power of 3 is negative 1. Okay, so now let's find out the values for all three of these. So 8 factorial, so that's 8 times 7 times 6, because that's over 5 factorial, so 876, and then divide by 2, and then multiply by this 2, so those cancel out, and then we have a negative 1 in there, so multiply by negative 1. So this one is 8 times 7 times 6 times 5, because there's a 4, that's the highest, and then 3 is 3 factorial is 3 and 2, so that cancels out with our 6. And then we have an 8 here. So I'll just write this on the side. So this is 8, 7, 6, and negative 1. This is 8, 7, and 5, and then 8. And then for this one, we have 8 factorial, which is 8 times 7 times 6, because there's a 5 factorial on the bottom. And then 3 factorial is 3 times 2 is 6, so we cancel with that 6, times the 32, times the negative 1. So this one's a 8 times 7 times 32 times negative 1. This would be easier if we have a calculator, but since we don't, we had to look for some common ways to work with this. So I noticed that there's an 8 and 7 on all of them. So 8 times 7 is 56. That's 56. That's 56. And now 6 times negative 1 is negative 6, so multiplied by negative 6. And then 5 times 8 is 40, so that's 40. And then 32 times negative 1 is negative 32. And since we're adding them, basically we just ignore the 56 and add these numbers. So negative 6 plus negative 32 is negative 38. Negative 38 plus 40 is 2. And then 2 times that 56 that we left out. And that should equal to 112. And that is your answer for number 17. Okay, and that covers the entire thing for our junior senior 8%. Thanks for watching, and I'll see you at the next math record.